back visiting this Mastech or Sine Wave MS 6100 frequency meter, multifunction counter, whatever. In part 1 of this series, I determined that this little circuit is a red herring. It provided a 10 megahertz output through this piece of coax to this B and C on the back, labeled oscillator out 10 megahertz. Well, that's true. This was a 10 megahertz oscillator. It was connected with the coax. The problem I've had with this meter is it's never been very accurate. Attempts to adjust this 10 megahertz oscillator weren't successful. I could adjust it, but it had no bearing on the front panel readout. Turns out this is not the time base. The time base is actually an 8 megahertz crystal right here, feeding the MCU. All of this is just for show. The time base consists of this crystal, this resistor, this little capacitor, and this variable capacitor. 1, 2, 3, 4 components. Schematic looks like this, with pins 21 and 22, which are labeled oscillator 1, oscillator 2, a 600K resistor, an 8 megahertz crystal, 2 capacitors to ground. And they are these fellows right here. My intention then is to remove these 4 components. Now the Holtec data sheet shows an oscillator, a crystal oscillator, between 1 and 2, which is pin 21 and 22. They also show an RC oscillator, which is just a source of positive voltage, I guess, and a relaxation oscillator. So, based on a couple of commenters, a fellow named Constantine and a fellow who identifies himself as T1D100, suggested this might be the case, where this is a placebo and this actually is the frequency determining thing. And Constantine suggests I replace the crystal with, I need to relabel these as part of making a mistake. And sending some sort of an 8 megahertz input through a safety resistor into pin 21, or oscillator 1. Remove these components and replace them with this sort of a thing. I've got the coupling set to DC, and this represents 0. Let me look on pin 21. So you see we have a sine wave looking signal above 0 with a peak to peak of 3.4 volts. But you see it never goes below 0. It's a sine wave that's above 0. That's pin 21. Pin 22 has a sort of distorted sine wave, about the same thing, floating above 0. So I need to try to, I hope, duplicate that signal. I have an 8 megahertz TCXO Now this is not an oven-controlled oscillator. Actually, this should be called a temperature-compensated crystal oscillator. It's not voltage adjustable. It's adjusted with this, well, I think you remove the screw to adjust it. It's 5 volts. I'm going to hook it up and see what it looks like. I've hooked this TCXO up dead bug fashion. And I'm looking at the trace on the oscilloscope. It's not quite 8 megahertz, but it is about 2.9 peak to peak. So I think I'm going to couple that is to say this signal, to pin 21 of the device. And I measured the current. This is 6 milliamps is all that's being drawn by this. Remember, it does not have an oven. It's just an oscillator. So I think I'll power it from the 5-volt power supply in the frequency meter. This doesn't look pretty, but here's a TCXO. It's getting 5 volts through this red lead. Chassis ground is carried over on this green lead. And this yellow clip carries back, and it's not pin 21, but it's pin 22. These leads out of the way. You can see I've removed the components. I've attached this wire to pin 22. Now, I powered up with no components, and of course there was no display. There's no oscillator controlling the MCU. I hooked it up to pin 21, and I got the same result. Here it is on the oscilloscope. You see it's about 150 hertz low. That is the oscillator. Driving pin 22. I have 10 megahertz coming into the unit. I don't know if you can see that or not, but it's 10, 220. So that probably is the fact that the clock is at 7999850 or 855. But it works. So now I need to find a more accurate time base. And I think this whole thing can be wrapped up. This transformer I noticed is rated 1 amp. This regulator, of course, is 7805. The 6 milliamps additional current doesn't appear to be doing anything. I knew this was not 8, and I adjusted it in the side here, and I could not get it to 8. But the concept has been proven. I modified this drawing, this part of it, I correct the numbers and stuff, and it will be in the directory below, along with a link to part 1 of this series. I'll do the whole thing again once I get a more accurate or a better time base, let's say. Thank you.